Hi, I'm Mark Barsamian. In the previous video, we had an introduction to the substitution method for integrals where the integrand involved a nested function. In this video, we'll again be discussing the substitution method, and we'll be considering slightly more complicated examples. The reading for this video is from section 5.2, Integration by Substitution, and more specifically, pages 333 to 343, examples 4, 5, and 6. The corresponding homework is this collection of exercises from section 5.2. The title of this homework set is Harder Substitution Integrals, Leftover Multiplicative Constant. Now, recall the integral rules that we have so far: the power rule, the 1 over x rule, the e to the x rule, the ln of x rule, the constant multiple rule, the sum rule, and the combination of those called the sum and constant multiple rule. And remember the substitution method that I presented in the previous video, this 5-step process. And remember that step 3 of that method was substitute, cancel, simplify. And recall that in the previous video, in all the examples that we did, there was no simplifying to be done. That is, after we substituted and canceled, we had a new basic integral involving just the variable u. Well, in the current video, which is titled Harder Substitution Integrals with a Leftover Multiplicative Constant, we're going to see that there is simplifying to be done. So the substitute, cancel, simplify step, that's step 3, will actually involve all three of those things: substituting, canceling, and simplifying. Well, let's just dive right into examples. Example 1, find this indefinite integral, the integral of e to the kx. So let's recall our procedure. Step 1, identify the inner function and call it u. Now let's see what step 2 is. Step 2 is to build the equation dx equals 1 over u prime du. There's our equation, dx equals 1 over k du. Remember that we circle this equation. I circled that in red in the previous video as well. Circle the first equation where we identify the inner function. Now remember that step 3 was substitute, cancel, simplify. So there's our step 3, substitute, cancel, simplify. Notice that we did substitute. We substituted using the green circled equation to make the green substitution, and the red circled equation to make the red substitution. Now what about the canceling? Well, there was no canceling to do in this example. But there was this leftover multiplicative constant, this 1 over k. The leftover multiplicative constant. That's what I mentioned earlier. In this video, we're discussing substitution integrals that are harder, and it's because there's this leftover multiplicative constant, which we deal with by simplifying. That's the simplification step. And we simplify using the constant multiple rule. So the complication is that there's this leftover multiplicative constant, but it's simple to deal with that. You just use the constant multiple rule. So you see then that our result of step 3 is this new basic integral involving u that is not involving a nested function, it does have this 1 over k out front, but the integral itself is a basic integral. Remember that the result of step 3 should be a new indefinite integral with an integrand that's a function involving u, no x's in that new indefinite integral. The integral should not involve a nested function. So we've done everything right. Now what's next? We've done step 1, step 2, step 3 was substitute, cancel, simplify. We've done that. Step 4 is to integrate. So we integrate. The integration of e to the u is simple. The integral of e to the u is e to the u plus c. Now we have this 1 over k in front. Remember that the 1 over k gets distributed to 2 places. So we end up with this term, 1 over k times our constant of integration. But realize that that letter c represents any real number. That can be any real number. So then that means that 1 over k times c can also be any real number. So we are at liberty to simply change the name for that expression and just call it d. d stands for any real number. Finally, step 5 is to substitute back. Now remember that when we do the substituting back, we end up with the answer to our indefinite integral question. So I'm going to write this as an integral equation. You can see that we substituted back, replacing that u with kx using that green circled equation. And there's our result. Now that's actually a very important result. In fact, we should add that to our list of indefinite integral rules. It's also worth reviewing our derivative rules. Remember that we have the e to the x rule for derivatives. The derivative of e to the x is just e to the x. Very easy to remember. And just as easy to remember is the e to the x rule for integrals. The integral of e to the x is e to the x plus c, of course. But remember that there was this more complicated rule for derivatives of exponential functions when the exponent had a constant next to the c. The derivative of e to the kx is k e to the kx. Now what we've just determined is that the indefinite integral of e to the kx is 1 over k times e to the kx. And then of course there's the plus c. So these two rules, one for derivatives and one for indefinite integrals, go together, and they're both very important. So we've done all 5 steps. Let's go on. Example 2, find this indefinite integral. Okay, well, let's just go step by step. So there are our first 3 steps. Notice that in step 3 we substituted. There was no canceling to be done, but there is a leftover multiplicative constant. It's that 1/4. And we dealt with that by using the constant multiple rule. Step 4 is to integrate. So there's our result of integrating. Notice that we used the power rule for indefinite integrals in going from this integral to this expression. And notice that we were very careful with our exponent calculation Minus 5 plus 1 equals negative 4. Notice that I was careful to write this 1/4 as a fraction in front, multiplying this fraction. So the u to the minus 4 stays out to the side, and I end up with 1/16 with a minus sign out front. And here's another one of those deals where I have a constant times my constant of integration. So since c can be any real number, 1/4 c can also be any real number. So I can just replace it with another letter which represents any real number. Finally, step 5 is to substitute back. When we do that, we'll have our answer. So I'm going to write my result of step 5 as an integral equation. Notice that I converted my answer to positive exponent form. The problem was presented to us in power function form, in the sense that we had parentheses raised to the minus 5 power. That made it convenient for finding the integral. All of these steps in the middle were nice, but in the end, when we end up with this expression involving u to the minus 4, it's convenient, it's nice to convert that to positive exponent form. 1 over 16 u to the plus 4. Let's go on. Example 3, find this indefinite integral, integral of 3x e to the x squared. All right, step 1. There's step 3. This is our first example in which we had to do all three things: substitute, cancel, simplify. In the substitute step, we did the green and red substitutions. In the cancellation step, we canceled those two x's. And then we had leftover constants. We had a 3 in the numerator and a 2 in the denominator. In other words, we have a leftover constant of 3/2. It's a multiplicative constant. So we simplify using the constant multiple rule. And we see that at the end of step 3, we have a basic integral with a constant in front. We're ready for step 4, to integrate. We integrate e to the u, we get e to the u plus c. We end up having the same situation where we have a multiplicative constant that gets distributed two places. We end up with 3/2 times capital C, which is our constant of integration. That expression, circled there in green, can be any real number, so we can just replace it with the symbol d, which represents any real number. Finally, step 5 is to substitute back. When we substitute back, we'll have our answer, so I'm going to present the integral equation. There is our answer. We substituted back using this green substitution to replace that u with x squared. And again, the final answer is this function form, which is what that indefinite integral symbol represents. Let's go on. Example 4. Find this indefinite integral. Well, I'll follow the same 5-step process. There's our complete solution. In step 3, notice that we had substitution to do. We always do in these problems. There was no canceling to be done in this problem, but there was some simplifying because we had a leftover constant. We had a 2 over 3, which is a multiplicative constant, so we simplified using the constant multiple rule. The result of step 3 was this basic integral. We did not convert that to a power function form. We did not write that as u to the minus 1. The reason is you can't use the power rule to integrate u to the minus 1. You have to integrate 1 over u using the 1 over u rule. The indefinite integral of 1 over x is ln of absolute value of x plus c. We integrated, obtaining a constant of integration, which was this number plus c, but there was a constant multiple in front of the whole expression, so that constant multiple gets distributed 2 places, leaving us with 2/3 c, which we just replace with the letter d. And then finally we substitute back using the green substitution to replace this u with this expression. And when we do the substitution back, we end up with this thing, which is a function form, which is what the indefinite integral stands for. So I write the final presentation of the problem as an integral equation showing what the integral equals. This indefinite integral equals this function form. That's the end of that example. Let's go on. Example 5. Find this indefinite integral. All right, I'll use the standard 5-step process. There's the full solution. Step 3, notice we had substitution to do as always. There was no canceling to be done. There was simplifying to be done using the constant multiple rule because we had this leftover constant. Again, the theme for today is the integrals involve this complication of having a leftover constant after the substitution and canceling in step 3. Notice again at the end of step 3, the result was a basic integral involving just u, no x. We integrated, we ended up with this constant of integration, but we also had a constant multiple out front, which got distributed both places. So we ended up with this new term, minus 1/17 c. Well, since c can be any real number, then minus 1/17 c can also be any real number. So we can replace this ugly circled expression with just plus d as a new constant of integration. Finally, we substituted back using the green circled equation to do this green substitution, replacing the u with that green circled expression. And again, the result of substituting back is this function form, which is what this integral symbol stands for. Let's go on. Example 6. Find this indefinite integral. I'll take the standard approach. There's the full solution. Notice that in step 3, we had to do all three things. We did our red and green substitutions. We canceling these x's that are both circled in black. And then we had a simplification step to do. We had this leftover constant, this multiplicative constant of minus 1/10. So we pulled it out of the integral sign using the constant multiple rule. So you can see that these problems with the leftover constant are slightly more complicated than the ones that don't, but it all happens using the same framework. We have the same instructions: substitute, cancel, and this should say simplify, not integrate. We use the same framework. In some of the problems, like the ones in the previous video, we had no simplification to do, but we did have cancellation to do. In today's video, we always have substitution to do, and sometimes have cancellation, sometimes we don't, and we do have simplification in the videos for today. Notice that when we did the integration, we ended up with a constant of integration, the plus c, which ended up being multiplied by this multiplicative constant, minus 1/10. So we ended up with minus 1/10 c. We replaced that with this new constant of integration, just a plus d. And again, recognizing that after we substitute back, using the green substitution to replace the u with this circled expression, after we do that, we end up with this expression which is a function form, which is what the integral expression represents. It represents that function form. That's the end of that example. Let's go on. Example 7. Find this very messy looking indefinite integral. All right, I'll follow the same 5-step process. There is the whole solution, which is about as messy a problem as we encounter in this course. Notice that the step 3 was quite involved. We had to do all three things: substituting, canceling, and simplifying. Notice how complicated our inner function was. It was this whole mess. Notice that we actually had an inner function that was itself a nested function. U was this circled mess, which had a nested function within it. We didn't have to deal with it. We just let u be the thing in parentheses, and everything else worked. We let u be sort of the biggest thing in parentheses. Notice again that at the end of step 3, we had a basic integral involving just u and not x, and not a nested function. It did have a multiplicative constant out front. We dealt with the multiplicative constant the way we've been doing throughout this video. In the end, we had that 1/15 times our constant of integration, c. That circled expression can be any real number, so we just replaced it with the letter d that could also represent any real number. And in the end, I changed the name back to c. Maybe I'll keep the name as d, so it's less confusing. And again, once we do the substitution back using the green circled equation to replace this green u with this green expression, once we do that, we end up with this function form, which is what this integration expression this integral expression represents. So I present the final answer as this integral equation, saying that indefinite integral equals this function form. That's the end of that example. Let's go on. Example 8. Example 8 actually has a typo. This is supposed to be the integral of x to the fourth in the top over that square root expression. All right, well, before we can integrate this, we need to rewrite the integrand in a more helpful way. Instead of 1 over square root of that stuff, we have that stuff in parentheses raised to the minus 1/2 power. Now we'll do the standard substitution steps. There's our full solution. This again is a very messy problem. The integrand was quite messy. It had to be rewritten in this more helpful form, but you can see that the structure of the problem is the same. The arithmetic gets messier. You have to be more and more careful, more things to keep track of. In particular, this fractional exponent, u to the minus 1/2, had to be integrated very carefully. The new exponent was negative 1/2 plus 1, which is just 1/2. We had to remember that dividing by 1/2 is the same as multiplying by 2. And we had the same issue involving a multiplicative constant times our constant of integration. So we renamed a new constant of integration plus d. Our final substitution using the green circled equation to replace this green circled u with this green circled expression gave us this final expression, which is a function form, which is what this integral symbol represents. So our final answer is this integral equation, saying that this indefinite integral equals this function form. And in the end, I wrote the final answer using radical form instead of fractional exponent form. I generally prefer fractional exponents to radicals, but in the case of the 1/2 power, I don't mind the square root symbol in that case. Let's go on. Example 9. Find this indefinite integral. Now this is a messy integrand. I'm going to rewrite it so that instead of having that expression ln of x raised to the 13 divided by x, I'm going to have it being multiplied by 1 over x. And then from here, I'll have the standard 5-step substitution method. And there's our full solution. Notice that we had substitution and canceling in the step 3, but we had no further simplifying. This problem actually could have been put in the previous video with problems like that where there was no simplifying to be done. Step 4, the integration step, was quite simple. We just had a basic power rule problem. We substituted back to reach this function form, which is what this indefinite integral expression represents. So I present the answer as an integral equation. There's one more example. Example 10. Find this indefinite integral. Well, this is clearly a nested function, so let's just do the standard 5-step substitution method. There we've proceeded through the steps of the substitution method and then reached a puzzling spot. Because notice that at this point we have an integral symbol that has both u and x in it. Inside that integral symbol there is both a u and an x. Let's go back to the beginning of the video and look again at the instructions for the method of substitution. In the substitution method, step 3, cancel, substitute, simplify. The result should be a new basic integral involving just the variable u. Let's go to the next page and see more remarks about that step 3. These remarks say again that the result of step 3 should be a new indefinite integral with an integrand that is a function involving the variable u. There should be no x in the new indefinite integral. It should only involve u. And it should also not involve a nested function. Our result does not involve a nested function, but look what else it says. It says if those two items are not satisfied, then either we made a mistake or maybe the original integral might be one for which the substitution method cannot be used. We have an example like that. Let's go back and look at our result. We've reached this step, we haven't made any mistakes, and we've reached an integral that involves both x and u. We can't go any farther. So what do? Well, we have to conclude that the substitution method doesn't work for this integral. Well, what do we do? If the substitution method does not work for this integral, what else should we do? Well, how about this? Notice that the integrand can be rewritten. Oh, so that means that our integral is actually not very hard at all. Now we've reached a point where we have to find the indefinite integral of ln of x. Let's go back and recall our indefinite integral rules. Remember the ln of x rule. The indefinite integral of ln of x is x ln of x minus x plus c. We'll use that in our final example. So our final result is this function form. Notice that I rewrote the constant of integration. We had a constant of integration that was this plus c, but there was a multiplicative constant out front, a 2, that gave us a 2c. Well, since the c could be any real number, 2c could be any real number. So I just replaced that 2c with this new symbol, d, which represents any real number. So again, we end up with this function form, which is what this indefinite integral represents. So I present the result as an integral equation. Now this example is very important because it points out, for one thing, the importance of being very careful when you do substitution integrals. Use correct notation so that normally when you do a substitution integral, you end up with a basic integral, a grammatically correct integral involving just u and not a nested function. In all of our examples, at the end of step 3, we had a basic integral, a basic indefinite integral involving just u. And notice it had all of the components of an indefinite integral. It had the integral symbol, which consists of this s-like symbol and the du. All of our step 3s ended with an expression like that, an indefinite integral involving just u that was not a nested function. It's important to always be that careful so that when you do a problem like this and end up with an integral that does not fit that requirement, we end up with this indefinite integral that involved both u and x. Then it sticks out like a sore thumb. You realize something's wrong here, and you have to just sometimes surrender and say that the substitution method does not work for some integral, and then hopefully find some other way. In this problem, there was another way, actually a very simple way to do the integral that did not involve substitution at all. So that's the end of that example, and that's the end of the video. Thank you.